Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session. My name is Dr. Russell Betts and I will be your guide through these problems. So let's jump right at it. Convert the following monosaccharides into Fischer projections. Alright, a Fischer projection is a very nice and useful and clean way of looking at a monosaccharide. So let's take a look at the top one. We can see that we have a whole bunch of carbons, a whole bunch of OHs, and a whole bunch of hydrogens. It's just kind of a hot mess. There's just a lot going on there. So we want to make it neater and make it a little cleaner, a little easier to understand. So the first thing we need to understand is that in a Fischer projection, the chiral carbons, the atoms, are not shown. Remember, a chiral carbon is a carbon that has 4 different groups attached to it. So let's look at this one here. This carbon has a hydrogen, an OH, an aldehyde, and this whole group down here. This carbon is chiral. Let's put a little dot by it. That carbon is chiral. It has 4 different things attached to it. This carbon is also chiral. It has this whole aldehyde containing group up here, this whole alcohol thing looking down here, this OH, and that hydrogen. This carbon is chiral. And I hope you all agree, so is that one. It has the CH2OH here, an OH, an H, a C3H a whole bunch, and O a whole bunch. I mean, they're just different. Okay? So these 3 carbons are chiral. This one's not. This one has 2 hydrogens on it, so it has 2 of the same group. This one has 2 bonds to oxygen, so it's not chiral either. It has 2 bonds to oxygen, same group. So now, when you're drawing a Fischer projection, just draw a line straight down like that. Draw in your aldehyde. Draw in your CH2OH. That is there, and that is there, okay? Now, the carbons won't be shown. So what we do, there's 3 chiral carbons. You draw 3 lines perpendicular to your first line. And draw in all the accompanying atoms. Okay? Now, locate it right here where the 2 lines come together. Remember in the skeletal structures, we said where 2 lines come together, that's a carbon. So right in here, it's not shown, that's a carbon. That's a chiral carbon. Excuse me. That's how we know it's a carbon, because 2 lines have come together. We know it's chiral because it's a Fischer projection. Only the chiral carbons are not drawn in a Fischer. So here, carbon, that's chiral. Here, a carbon, that's chiral. And here, a carbon, that's chiral. Okay? Let's do this one. Let's first identify the chiral carbons. Here, 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 and here. CH2OH is not chiral. That is not chiral. Draw your line straight down. Draw in the aldehyde. Draw in your CH2OH. And we have 1, 2, 3, 4 carbons. So we'll draw 4 perpendicular lines. And the length doesn't matter. I'm just doing it freehand. If I was doing it with a computer, I'd make the lengths perfect. But don't worry so much about the lengths. Just as long as the idea is there. Okay? And there is the Fischer projection of that molecule there. So, really, what I could do, and I'm going to do it right now, I can draw equals signs like that. This drawing equals that drawing. This drawing equals that drawing. This drawing is the same as that one. This drawing is the same as that one. They mean the same thing. All right? This is a standard drawing. This is a Fischer projection. This is a Fischer projection. This is a standard drawing. All right? And that's how you do it, guys. All right, if you weren't clear on how to do that, please contact one of the tutors here at the Academic Success Center. Get this stuff straight. It's really easy. We are going to use these quite a bit, so you don't want to be left behind not knowing how to draw them. Okay? So with that, I'd like to wish you good luck and good chemistry.